Okay, we're starting chapter 11, which is circumference and arc length. There's going to be two parts to this section of notes. There's a lot of content. So the first thing I'm sure most of you guys have heard in previous math classes is circumference. So the circumference of a circle is the distance around the circle. So basically, if you were to take a tape measure and put it around the circle, it's like the perimeter of a circle, but we call it circumference. Now, the formula, circumference, is equal to 2 times pi. Pi is 3.14 if we round it, times whatever the radius is. Now, if you combine the 2 and the r, 2 times radius is diameter. So you could also say that the circumference is pi times diameter. You can either use 3.14 in your calculation, or there's going to be a pi key on most calculators. And that'll give you a little bit more accurate, but make sure you always follow the directions on if it specifies for you to use 3.14, because that will give you round off error if the program didn't account for it, so when you input your answer. All right, so let's do an example using that. Find the indicated measure rounded to the nearest hundredth, so that's 2 decimals. The circumference of a circle with a radius of 11. So that means the r in the circumference formula is 11. And since they gave us r, we might as well use circumference equals 2 times pi times 11. And it says to round the decimal. So when you enter this, it doesn't say leave it in terms of pi. If it said leave it in terms of pi, you would want to just say 22 pi. But since it doesn't, we're going to type this in. So 2 times, is it going to work? Maybe we got to turn it on. Let's try this. 2 times, you can use the pi key here. This is a Inspire, so let's see where the pi key might be. Right there. Times 11. Enter. Now 6.115 or 69.115 because I can't read. So 2 decimal spots is going to make that one a 2. So this would become 69.12 inches. All right, let's look at B. Radius of a circle with a circumference of 4. So now we're going backwards, 4 millimeters. So this is C. We're going to use the same formula. We're just going to fill in circumference instead. And since 2, pi, and r are all multiplying together, we're going to divide out what we don't need on both sides. And then radius is going to end up being 4 divided by 2 pi, or 2 divided by pi. So when we do this, where's clear? Oh, it's so weird using the computer version of this. So when we do this, we have to do the divide key. So 4 divided by, now if you choose, make sure just to be safe you do parentheses, 2 pi. That way the calculator doesn't accidentally divide by 2 and then multiply that by pi. So we get 0.63662, and it doesn't specify. It did in the original. So again, 2 decimal spots. So 0.64. So that's going to be millimeters. All right, now we're moving on to arc length. So an arc length is the portion of the circle, of the circumference of the circle. So in the last chapter, we did arc measure. So I told you guys in the beginning of last chapter that you had to be really careful not to confuse arc length and arc measure. So we did lots of stuff with arc measure, which is measured in degrees or radians. Arc length is literally a part of that tape measure, okay? So instead of going all the way around, you're just going to go for part of it. So arc length is part of the circumference. arc measure is degree. Arc length is like millimeters, centimeters, inches, that type of thing. So there's two different ways that you can calculate arc length. You can either use a proportion, so you can say like the length of the arc divided by the whole circumference 2 pi r equals the measure of the arc divided by the whole measure of the circle 360 and cross multiply. Or you can do the arc length of AB. All right, so once again, arc length is a portion of the circumference. So it's like a fraction. For the most part. So the measure of your arc length, so that's like your actual, like your central angle, your measure, divided by the whole measure of the circle. That'll give you your like your percentage or your fractional part of whatever you're trying to measure. So that's what this one says. If you take your fractional apart times 2 pi r, that will give you, so if your central angle is 180 out of 360 is 1/2, and that would give you 1/2 of your circumference. So let's do a couple examples. Find the indicated measure. So you're looking for arc length. B, you're looking for circumference. And this is the measure of your arc. Okay, so notice A, they give you the angle. C, they give you the arc length. This is measure. This is length. Okay, so be really careful. You can look at the pictures and see that they look pretty identical, but you have to be able to read the words and know what they're asking. So first one, arc length, that means they want this right here. They want that part of the tape measure. So this is going to be the angle of the arc, 100, divided by the whole circle, times the circumference, 2 pi times radius. So I'm going to simplify this up a little bit. So we're going to have, this is 24 pi times 100 divided by 360. So if you wanted, you could put this whole thing in the calculator, or you can simplify it. But if you simplify it, you got to be careful that you don't accidentally simplify it wrong. So if you were to put it in the whole thing, and again, not all of you guys use Inspires, if any of you, so if you use Mathway or something, it's going to be a little bit different. Oh. So 100 over 360 times 2 pi times 12. So we get 20.944, and it doesn't specify what decimal. So try this again. All right, we're looking for circumference, which is 2 pi r. So we have circumference equals our arc length, our angle measure, 130 divided by 360 times 2 pi r. This right here is what we're solving for. So this right here is our arc length, not C. I didn't mean to put C. So 6.5. All right, so we essentially just have to multiply both sides by 360 over 130. So our circumference is equal to 18. All right, C, your arc measure. So arc measure here, 21. So we have 21 equals our central angle, we don't know, divided by the 360 times 2 pi times our radius. So now we are finding that angle. So you can figure out what all of this is in your calculator. So we can do, I can make that bigger. Let's do 2 pi times 14.32 Well, that didn't help me very much, did it? And then divide that by 360. So that gives us 0.2499, and then make sure we got that divided by 360. And divide 21 by that. And we get 84.02 degrees roughly. All right, so now we're going to go from how to change degree measurement into radians or radians into degrees. So 2 pi radians is the same as 360 degrees. And all it really means is that, like on pre-calc and stuff, we use radians for a lot. Calculus, the higher levels of math. And for right now, we use 360. That's kind of like inches and meters, that type of thing. A lot of calculators will convert for you, but if you are stuck doing it by hand, if you multiply the degree measurement by pi over 180, it will switch it to radians. And likewise, if you're given radians and you need to switch it to degrees, you'll just flip that over. So think of your conversions. If you're converting like 12 inches to 1 foot, you want your inches to be in the denominator here, and whatever you're trying to convert it to be in the top. So this guy stays, but these cancel out. Same thing is going on here. If you want to switch to radians, you want your radian measure to be on top. If you want to switch to degrees, you want your degree measure to be on top. So convert 30 degrees to radians. If you want radians, you need the radians on top. So that's pi over 180. And then multiply it by the degrees you were given. So the degrees cancel, and you are left with, it doesn't say, well, it's in radians. You could have a decimal, but we can just leave it in terms of pi. So the zeros cancel. 3 divided by 18 is 6. So we have a 6 on the bottom times pi. Or you could write this pi over 6. If they ask for the decimal, then you could do that in the calculator and get the decimal. But usually when you have a radian measurement, they want you to keep it in pies. All right, so know that 1/6 pi or pi over 6 is all the same thing. All right, now convert radians to degrees. So we want degrees on top, so we're going to do 180 over pi, and then multiply it by the radian degree, or the radian measure given. So the pi's will cancel. Then if we multiply across, we would end up with 3 times 180 over 8. And then when you put that in the calculator, you're going to get 67.5 degrees. All right, so moving on to the second part of 11.1 is just some application problems. So we have the radius wheel of a toy truck is 4 inches. So we got this toy truck, one of the wheels, the radius is 4. To the nearest foot, how far does the wheel travel when it makes 7 revolutions? That means 7 times around. So that means this whole wheel rotates around 367 times. So 360 degrees times 7. So basically, how far does the wheel travel? This is saying like distance that the wheel traveled from start to stop. We call that the linear measurement. It means if you took a tape measure and laid it out, how far did it travel? So all the way around the circle, when it starts here and travels 360, it would be like if you unraveled that circle and made it like a straight line. So that's the circumference. All right, so we're going to say it traveled this distance 7 times. So 2 pi times radius times 7 revolutions. If we put that in the calculator, we get roughly 175.93. And it wants to the nearest foot, so we're going to just round that up to about 176. Oh, sorry, nearest foot, this is in inches. That's another thing you guys got to be really careful of. They'll switch that type of thing. So this is in inches because the radius is 4 inches, and since they want the nearest foot, we're going to have to convert that. So we're going to divide this by 12 inches because there's 12 inches in 1 foot. And when we divide this, we end up getting, and then we round it, we get approximately 15 feet. All right, so a lot of algebra happening there. All right, let's look at this one. This looks intimidating. Find the perimeter of the shaded region. All right, so they just want the perimeter, not the area. So we have these 3 5s. Perimeter is like adding all the lengths around. So 5 plus 5 plus 5. And then we have these 1, 2, 3. Now, if you notice, this is 120. 120 times 3 is 360. So if all these are the same, these are all 120. So basically, if you put these 3 together, you get one full circle. Okay? So 2 pi r. If we add them all, you can't say 360 because that's the measure of the arc, not the length of the arc, and perimeter is length. So be careful that you don't do 360 on accident. So yeah, 15 plus 2 pi times the radius is going to be half of 5. So from here to here and here to here is 5. So that makes the radius half of that. So if you put this into the calculator, we end up with 30.71 roughly. And we don't have if it's inches, it's just units. And then we have another one similar to the previous one. So a path is built around 4 congruent circular fields. The radius of each field is 100 feet. How long is the path round to the nearest 100 foot? So same type of thing. We can see going across from here to here is 2 sets of 100. So we know this is going to be 200. This is going to be 200 because they're all congruent circles. And this part's going to be 200. And then we have this arc measurement, and there's 4 of them. And if you notice, this is going to be 90. It's going to be 1/4. So again, 4 of these arcs is going to create one circle. 1, 2, 3, 4. Okay, so same principle. We're just, instead of 3, it's 4. So we have 200 4 times, or 4 times 200. I'm just dragging this out. Plus our circumference of one full circle, 2 pi times radius, which is 100. So we put that in, and we end up with about 1428.32. But they want to the nearest foot, so we're going to have to round down. So about 1,400 feet.